All right, year 9. So we are looking at trigonometry for our next topic. Now, the most important thing that you need to realize is that trigonometry, when we're dealing in trigonometric functions, is all about proportion. Okay? If we have a right angle triangle, the first skill that we need to learn is how to label the sides of a triangle in regard to a given angle. So, first of all, we have a symbol called theta. All right, spelled like this, and that is used to represent angles, okay? Along with this, we sometimes use what is called alpha. And in very rare circumstances, we will also use beta, okay? And these are just different ways or different letters that we use to represent an unknown angle so that they're not confused with this is for x or y, which we might use for given sides, okay? So you'll notice for each of these, I've drawn a small circle at the top right-hand corner. This is your degrees, okay? All angles are given in degrees in year 9. So if you have, for instance, 60 degrees, you would write it like this, okay? 60 degrees. Now, in terms of labeling our diagram, we're going to label it with 3 different terms. We're going to label each side. We're going to label it O for opposite. We're going to label it A for adjacent. And we're also going to label it H for hypotenuse. Now, the one that we're going to start with is your H value, your hypotenuse. Now, your hypotenuse is always the longest side. So in this case, it is the longest side here. We're going to label it H. Remember, it is the longest side. All right. The next one that we're going to label is our opposite. Now, opposite means opposite from theta. So, looking at theta, we're going to draw a line, follow it all the way along. The side that is opposite is the side that does not touch theta, which is this side here. So that is our opposite side. Now, this will change. If, for instance, we had an angle in this corner, so our theta value is here, our opposite side would be here, because that is now opposite from the angle. Our hypotenuse, being the longest side, will never change for this triangle. Okay? But going back to our original example, where this was the given angle of theta, we're going to say that this is our opposite side. The last side is the side that touches theta. The last side is our adjacent, which is this side here. And adjacent can always be remembered as the one that is in direct contact with theta, that is not the longest side. So the longest side is your hypotenuse. The other side that touches it is your adjacent side. All right. Now that we have labeled our triangle, okay, we're going to start looking at our trigonometric functions, okay, and our ratios. So, moving on, we have 3. The first one is called sine. Okay, it is abbreviated to sine, S-I-N, and the ratio is that sine of theta degrees will give us a ratio of opposite over hypotenuse. Cosine, also referred to as cos, of theta degrees is equal to the adjacent over the hypotenuse. And finally, tangent, abbreviated to tan, of theta degrees is equal to opposite over adjacent. Now, this is a lot to remember. You will be allowed a boundary reference, but one of the best ways that you can remember it is to remember so, ka, toa. So kind of like sakata, we have so, ka, toa, where that is saying that we have sine is equal to opposite over hypotenuse, so SOH, cos is equal to adjacent over hypotenuse, so CAH, and tan of theta degrees is equal to opposite over adjacent. Okay? So this is the first, this is what we're looking at. Once we've labeled our triangles, we start working with these to find side lengths and angles within a triangle. So I'm going to give you a quick example of how to apply these to a triangle to get the given ratio. We're not going to be solving for a side length yet. That is going to happen in the next video. So you have a given triangle. Must be a right angle triangle for this to apply. We have our given angle, which is theta degrees. And we're going to have some side lengths here. So I'm going to say that's 4, that's 3, and that's 5. And we're going to look at what fractions we will get when we apply our trigonometric ratios, our trigonometry ratios. So if I were to get sine of theta, the first thing I need to do is label my 3. So my first thing I label is my hypotenuse, which is the longest side. Then we're going to label the side that is opposite from theta. So if that's theta, the side that does not touch it, that is opposite, is this side here. That is our opposite side. Finally, the side that touches theta, that is not the longest side, is of course our adjacent side. So sine of theta is equal to, from SOHCAHTOA, SOH is going to be opposite over hypotenuse, which in this case my opposite value is 3, over my hypotenuse value, which is 5. So sine of theta is 3 over 5. For this triangle, cosine, or cos of theta, is equal to adjacent over hypotenuse, which in this case my adjacent value is 4, and my hypotenuse value is 5, with 4 over 5. Finally, we have tan of theta degrees, which is equal to opposite over adjacent. In this case, the opposite is 3 over our adjacent, which is 4. So that's just a brief introduction to our trigonometry ratios and how to use them to obtain fraction values of a right angle triangle. Good luck.